Yeah.
What is the actual answer to the question? Angularity.
Okay, so that's very good. So here we go. Find the largest area enclosed. So that's sort of a trick question, isn't it? So there are various. That's a good thing to ask. That's sort of a trick question. Why? Because according to the rules, we're trapped between the two maxima at something which is strictly below. So in other words, one answer to this question would be, and this is the answer that I would probably give, is 1/16, but that's not really true because that's only in the limit. As x goes to 0 or as x goes to 1 minus. And if you like, most is when you've only got one square, which it breaks the rules of the problem. All right? So essentially, it's a trick question. Right? But I would answer it this way, because that's the most interesting part of the answer, which is that it's 1/16, and it occurs really when one of the squares disappears to nothingness. All right. So now let's do another example here, and I just want to illustrate the second style or the second type of question. Yeah.
I'm wondering, okay.
So the question is, since the question was, what was the largest area, why did we find the least area? The reason is that when we go about our procedure of looking for the least or the most, we'll automatically find both. Because we don't know which one is which until we compare values. And actually, it's much more to your advantage to figure out both the maximum and the minimum whenever you answer such a question. Because otherwise, you won't understand the behavior of the function very well. So the question, we started out with one question. We answered two questions. We answered the question of what the largest and the smallest value was.
And also, I'm wondering if we can check for the minimum, whether it's a minimum or maximum point using the second derivative.
Yes, one can also use, the question is, can we use the second derivative test? And the answer is yes, we can. In fact, you can actually also stare at this and see that it's a sum of squares, so it's always curving up. It's a parabola with a positive second coefficient. So you can differentiate this twice. If you do, you'll get an eighth plus another eighth, and you'll get a 16th. So the second derivative is 1/16, is 1/4. And that's an acceptable way of figuring it out. I'll mention the second derivative test again.